pop quiz. Look at acetone. How many different proton NMR signals would you expect? 1, 2, 3, or 6? The answer is just 1, because all 6 hydrogens are equivalent, and that's our key idea. In this video, you'll learn what proton equivalence means, how to use the replacement test to classify protons, and how terms like heterotopic, homotopic, enantiotopic, and diastereotopic predict what you'll see in a proton NMR spectrum. First things first, chemically equivalent protons see the same magnetic environment and share one signal, with integration adding up all those identical hydrogens. By contrast, non-equivalent sets give separate signals. So, how do we decide equivalence? The fastest way is the replacement test. Replace one proton with a dummy group X, then the other, and compare the two new molecules. That comparison tells you whether the original protons are equivalent or not, and if not, what kind of non-equivalence they have. Consider case 1, heterotopic. If the replacements give different constitutional isomers, the protons are heterotopic, chemically inequivalent. They appear as separate signals. Next, case 2, homotopic. If the replacements give identical molecules, the protons are homotopic, chemically equivalent. They collapse into one signal, with integration reflecting the total number of those hydrogens. Now, moving on to case 3, enantiotopic. If replacements give mirror image molecules, the protons are enantiotopic. In achiral solvents and reagents, they're chemically equivalent, but in achiral environment, they become non-equivalent and may appear as separate signals. Finally, case 4, diastereotopic. If replacements give diastereomers, the protons are diastereotopic, chemically inequivalent. They usually appear at different chemical shifts and may also couple to each other. That wraps up the 4 key categories of proton relationships. Curious how much you're remembering? Your personalized practice test, flashcard set, and study guide are all waiting for you. Just tap the link now and keep watching. Future you will thank you. Now, here's one caution. Don't confuse conformational change with different molecules. If the two X products are just conformers of the same compound, those original protons are still equivalent. Let's work through examples. As we saw in the pop quiz, the two methyl groups are related by symmetry. All 6 protons are homotopic, giving one singlet that integrates to 6. In ethanol, the two CH2 hydrogens are enantiotopic. In achiral conditions, they give a single signal, integrating to 2. However, place a stereocenter nearby, and those same hydrogens no longer overlap. They split into 2 distinct shifts, often as AB or ABX patterns. To speed things up, here are 3 quick checks. A, ring versus benzylic methyl, that's heterotopic. B, 2 methyl groups related by symmetry, homotopic. C, ACH2 next to a stereocenter, diastereotopic. The replacement test confirms them every time. To recap, if the substituted molecules are identical, the protons are homotopic and give one signal. If they're enantiomers, the protons are enantiotopic, equivalent in achiral media. And if they turn into diastereomers or different isomers, the protons are inequivalent, showing separate signals. Now that you've watched the video, let's see how much you remember. Head to the link in the description where you'll find Quizlet content made just for you.